These 4 nights we'll have observed something like 15,000 stars. Our goal's 1 million over a few years, and so every little bit counts.
Definitely. So can you tell us then what we're seeing on some of these screens? There are lots of screens around here.
Yeah, so this is how we control the telescope. And so there's a computer at the AAT, the Anglo-Australian Telescope in Coonabarabran, that looks exactly like this, and we are just remote VNC connected into it. And so we see the same thing that's on that screen and vice versa, same way you might use Chrome Remote Desktop or any other VNC client. And so this computer is physically directly below the telescope. If we were there, we'd be sitting in the control room underneath the telescope using this. Not in the same room, of course, it's in the basement below the telescope because the lights are off where the telescope is right now, hopefully. And so we see everything you need to control the telescope. We talked earlier about the data coming off that we can see to make sure things look okay. There's a control here that we tell the computer how long to expose the camera for before it starts reading out the detector, where we're pointing the telescope, what field, how to set up the next field, how to position in this field that we're looking at, this kind of 2 degree in the sky region. For comparison, the moon is half a degree, so the field we're looking at is 4 times the diameter of the moon. Taking 300 stars in there, and there's a little robot that positions fibers to get data from these individual stars down through the telescope, through the detector and onto our hard drive. And so this screen over here tells the robots how to position each of these individual fibers. And so we have all the pieces of information we need, also information on what time it is, when the moon will rise, when the moon will set, when twilight will start, so we can make sure we're on track. And then we keep over here weather, the all-sky camera near the telescope, and so you can see up here at the top there's some clouds rolling in. We're going to hope those don't get here too quickly, but they are moving this way. And it's pretty much it. 8 monitors, all you need.
So what monitor are you looking at most when you observe something? Do you get the results straight away? Is it instantaneous? Which screen are you looking at?
Yeah, so mostly I look at the one right here with these green bars that says what's the status of the current observation. And so we take data for 30 minutes at a time. This is in seconds, 1800 seconds. And you can see this one has about 415 seconds to go. So those are going along, so I can see the status that everything looks okay. And I'm watching the weather to make sure that any clouds that roll through are not going across where we're looking, and our observations are as clean as they can be. Those are the ones I'm watching the most, but everything else has information on it that if something starts going wrong, we can look very quickly to try to understand what is happening. Is it something that is going to mess up these observations, or is it something that's we don't have to worry about too much? And then once this reaches the end of the exposure in 5 minutes now, the data will read out. It takes about a little over a minute to read out the detectors, and then we'll see the new images here, the new spectra. These are the format that they're presented in. It's hard to interpret any science from them. It's hard to say this is what elements are in each individual star, but it's useful to make sure that we're getting the stars that we think we're getting. There's enough information here. Nothing has gone obviously wrong with the data.
Okay, cool. So what does how does it actually collect the data? Is it just counting photons that land on each part of the telescope? What's happening?
Yeah, so let me open up a picture here. So this is what the telescope looks like with a person for scale. It's about 4 meters in diameter. And the instrument we're using attaches directly on here on the back of it. And so light comes in through the telescope, bounces off the primary mirror, and then goes right into this detector where there's a whole network of fibers. And so the first thing that happens is the light is broken up. You can think of it as going through a prism. That's not exactly what it is, but it's the same idea, where when you shine light through a prism, all the colors get spread into different directions. Blue light goes over here, red light goes over here. And then we place a detector at the end of that, and so each individual star we get, it's like it's gone through a prism, and we can see what is its intensity, how many photons do we get as a function of wavelength, and so at every color. And that's then what we see here. And so we record that in 4 different wavelength bands. The bluest one is kind of the blue optical, about 450 nanometers. There's a lot of hydrogen there, and some other iron lines and other things that are important. And they go all the way into the infrared. So the reddest one is at about 900 nanometers, which is just beyond where your eye stops working.
Cool.
One thing we haven't really talked about tonight is that the sky above us, even when there aren't clouds, is changing all the time. When there's wind or big temperature gradients, the way that the air, or that the light travels through the atmosphere changes in time. The atmosphere is always moving, and so light doesn't take the straight path down. It gets deflected by currents moving through the air and turbulent processes, and that spreads out the stars into something wider than just the kind of theoretical limit as to how small a star should be. You see this at night when you look out in the sky. This is why stars twinkle, because the atmosphere above them or above us, between us and the star, is bouncing around a little bit. And the more your atmosphere is changing, the more twinkling you have. That's bad when you have a telescope with a small little fiber that you're trying to put all your light into. And so the more turbulence, the worse, we call it, the seeing is. The fewer photons we actually get from our stars, and the more spread out they are physically on our detector. So tonight's seeing hasn't been amazing. At this site, we measure the seeing as an angle, and typically it's a decent night is about 1.5 arc seconds. So for an arc second, there's 60 seconds in a minute, 60 arc seconds in an arc minute, and 60 arc minutes in a degree. So the typical size of the star is 1.5 arc seconds. Tonight it's been between 2.5 and 3 for most of the night, which kind of slows things down a little bit. It just means we need to spend more time on every field to get as many photons as we want from the stars. You can kind of see, this isn't the most useful image, but this is an image of one point during the night, what the stars look like. And so we see how many pixels they take on each detector, or how many pixels on the detector, how many pixels each star takes up. And because we know the physical size of the detector, we can work out what the seeing is above us, because we know the stars are, in theory, infinitesimally small because they're so far away that their angle is effectively 0, up to the diffraction limit of the telescope. So the main effect is the seeing. We can measure it right away and understand how much time we need to spend on each field. So tonight we spent extra time because of the seeing. We only did 3 fields. Our hopes were to do about 5 fields. So more or less we lost 1 field because of weather, and 1 field because the seeing was bad, so we had to add time on the other fields. So 3 fields is better than 0. That still means about 1,000 stars were observed by us tonight, and so we'll have another go tomorrow. So seeing.
Yes, I was just going to mention it. We've got 3 minutes till, so I'd say you might as well start now.
Yeah.
Clouds are coming in right on schedule, so.
Yeah, we'll get as much as we can until they get here. It's a faint field, so we can find a good star here. That work. So it's probably this star. Let's verify that. Yes, that's there. Good. Good. Okay, so we'll run the focus script here. Oh, this is already so much better than last night.
When it didn't do was encouraged.
Yeah, for sure. It's hard to imagine focus script looking much better than that.
That's a nice, yeah, you can always tell when the setting is good.
Yeah.
So the number it is suggested is,
38.49.
yeah, well, that's where I started. That was my guess at the beginning of the night.
Yeah, so that seems very good. It's almost no change. What's wrong with it?
Okay, you can call that as 1.8, is it?
Yeah, let's call it 1.7.
1.7.
Yeah.
Okay, I didn't see all of them.
Yeah, there were a few that were better than 1.8 and none that were worse. So
Okay.
yes, I've parked the FPI, and I think are we guiding?
But I can't see any stars.
Okay. Could be a problem related to those clouds. But I have parked it.
No, I don't think so. I think it's just that they're. Did you do a shift click?
I did a shift click, but not a control click.
Control. Oh, okay. Yeah, right. It may be just too far off. Could you go? Sorry, that was. I probably confused you from last night. Just do the control click this time.
Perfect. I can do that.
And could you center using survey, please?
Could you say that again?
It's okay. It's already in. Probably just, I like for the first one tonight to do a center the gantry using survey. That's an option in the gantry control.
Okay.
No, down
over here?
there. Click. Okay, that's it. This is the one which just is like a calibration of the FBI against the plate.
Sure. Okay.
It doesn't matter. It doesn't have any effect if you observe. The last time you observed or did this, you were in a similar position. But it can be an issue if it was done when the telescope was a long way over, or and it applies, it enshrines that flexure.
Sure. Okay.
Okay, see
Yeah.
see the
That's
tiles there?
Pretty big move, yeah. And we were way in the south at the end of last night.
Okay, so now just continue with your normal acquisition now. So you're now going to, you've got to select an object, of course, because it's only centered at the moment. Isn't it?
Good. Okay, go to RA deck. Take image. Alright, then I'll control click on this one.
Yeah, please.
Good, okay.
Okay, now just move park the engine now.
Parked.
Did something come in?
There's a nice looking star. Let's find another one.
So you found two objects.
Yep. Right there.
Good.
Check another. Good bright one.
Right.
Yeah, seem to be popping up right where I expect them to.
Right, if you can put the light at the park again, please.
Sure. All right, should be parked.
Right, now just to be absolutely certain, you're in plate 1, and plate 1 is the field you want to be screwed to.
Yes, we have configured to the observation plate file that is the right RA deck. We should be up and right, which it looks like we are. Yes, those are the correct coordinates.
Now,